How are you, my dear learners, and welcome to my another video where I am going to attempt to teach you a subtopic on the main topic acid, bases and salts. And in this video I am going to focus on how to prepare salts. Without wasting your time, we are going to go through the learning outcomes so that you understand what you are expected of understanding at the end of my video lesson. So my subtopic in this video is on preparation of salts, and I am going to teach preparation of salts according to the methods we use to prepare salts step by step. In this lesson today, I am going to target the method of salt preparation known as neutralization method. Now, I expect you at the end of the lesson to be able to define a salt. It will be just a recap where I will request you to remember on how a salt is defined. Another important point, you should be able to list different methods used to prepare salts. A third important objective should be for you to be able to outline the procedure used to prepare soluble salts. So today we are going to be discussing how soluble salts are prepared. The fourth point, you should be able to explain in detail the preparation of soluble salts and give examples of soluble salts. This is very important. Once you are able to do whatever I've listed on my learning possible outcomes, then you are going to consider yourself that you have successfully understood the topic or the subtopic for today. According to my objectives, I listed a point that you should be able to define a salt. So without wasting time, I am going to explain what a salt is. So we are saying a salt is a chemical substance formed when the hydrogen ions in an acid are replaced by a metal or ammonium ions. Knowing the definition is not enough, but understanding the science behind the definition is very important. So when we say a salt is a chemical substance formed when the hydrogen ions in an acid are replaced by a metal or ammonium ions, we mean here we are reacting a reactive metal and or ammonium ions with an acid in order to produce a salt. What do you need to understand? Why are we involving ammonium ions in this definition of a salt? Now, we understand all of us that ammonium is the only radical with a positive charge, and we understand that all metals react by losing electrons, and when they lose electrons they form positive charge. For example, sodium. When we look at sodium, after losing an electron, it is going to form a positive charge. Now, since ammonium also have a positive charge, it behaves more like metals in reactions. That's the reason why when we are using a base formed from ammonium, for example, ammonium hydroxide, when we react ammonium hydroxide with an acid, ammonium is going to react just like a metal. That is very important. And you should understand that every acid contains hydrogen ion as the only positively charged ion. That's the reason why reactive metals are able to displace hydrogen ion from its acid, and the metal is going to take the part of hydrogen ion to form a substance salt. Now let us look at the methods of preparing salts. So we are saying methods. The first method we are going to discuss today is known as neutralization method. Neutralization method is one of the methods which is used to prepare salts. In future, we are going to discuss replacement method or displacement method, and then we'll discuss synthesis method, and lastly we are going to discuss precipitation or double decomposition. So for today I am going to explain how salts are prepared using neutralization method. Moving forward, we are going to target now the same method known as neutralization. Now, by definition, we are saying neutralization is a reaction between an acid and a base to form a salt and water only. So, when we are reacting a base with an acid, what is formed is a salt and water only. Now, we are not going to forget that there are some salts that behaves like bases. So by that I mean you don't expect us just to discuss bases that are known by their characteristics, but we are also going to look at some of the basic carbonates that are able to react with acids in order to form salts, water, and carbon dioxide. So by that I mean they are basic salts that are able to react with acids also to form a salt under neutralization, as I am going to explain where we are going. Now, neutralization includes the preparation of salts by reacting, number one, we can prepare a salt under neutralization by reacting a metal hydroxide with an acid. Now, this metal hydroxide we are talking about should be in form of an aqueous. An aqueous solution is the solution in which a solvent, or should I say water, acts as a solvent. For example, we may have sodium hydroxide, which is a base in aqueous state. Aqua means water. It means sodium hydroxide was initially in solid state, and then after dissolving it in water, it forms an aqueous solution. Now, when we react that aqueous solution with dilute acids, we are going to prepare a salt. Remember, we are talking about the preparation of soluble salts. So here we are talking about a metal hydroxide which should be able to react with dilute acid in order to produce a soluble salt. Now, this metal hydroxide in aqueous state is known as an alkali. We can also prepare a soluble salt using an insoluble metal oxide with a dilute acid. In this reaction, we react an insoluble metal oxide with dilute acid. If we are not using an insoluble metal oxide, we can also use a metal carbonate with dilute acid. So in this case, we are reacting metal hydroxide. If not metal hydroxide, we are going to react insoluble metal oxide. If not insoluble metal oxide, we can also use a metal carbonate, where we react metal carbonate with an acid. Now, we need to understand something scientifically. When we say metal carbonate, for example, magnesium carbonate, here I am going to explain why a metal carbonate can be used to prepare a soluble salt. Because there are questions like, since we are talking about the reaction between a base and an acid, why are we using a metal carbonate? Is a metal carbonate a base? That is the very normal question. Now, the science behind magnesium carbonate or any other kind of or type of a metal carbonate, you need to understand that all carbonates are basic in nature. By this I mean metal carbonates are formed between a weak acid and a strong base. Now, since the weak acid, which is carbonic acid, is going to react with a strong base, the name of the salt which is going to be produced will be a basic salt. Now, since that salt, such as magnesium carbonate, is going to be a basic salt, this salt is going to possess the characteristics of bases in such a way that when it is reacting with an acid, it will be reacting as a base. That's a reason why we are saying a metal carbonate can also be used to prepare a salt. Moving forward, I am going to explain very fast the preparation of soluble salts by neutralization using metal hydroxide. So we said we use a metal hydroxide which will react with an acid to form a salt and water. For example, we are going to attempt to prepare sodium chloride. The reagents we are going to use will be sodium hydroxide in aqueous state, which we are going to react with hydrochloric acid. Now, in your exam, you may be questioned maybe to identify the possible reagents that can be used to prepare sodium chloride. That question should be very simple for you, because you are going to be thinking of scientific substances that can be identified and being suited to be used in the chemical reaction as for us to prepare sodium chloride. First thing, you need to think of a base. So the possible base you are supposed to use, you need to look for a base which is going to contain a metal sodium, because the salt we are preparing is sodium chloride, so a metallic part need to give us sodium. So we need to react sodium hydroxide, and the non-metallic part of the salt is a chloride. So we need to look for an acid which is going to contain a chloride, and that will be hydrochloric acid. So in this case, we are going to say sodium hydroxide and hydrochloric acid are the possible reagents we are supposed to use in order to prepare sodium chloride. What will be the products? We understand that when we have sodium hydroxide like this, reacting with hydrochloric acid, this substance in aqueous state will ionize to form hydrogen ion and a chloride ion. The sodium hydroxide will also ionize to form sodium ion and the hydroxide. Now, the acid will react with sodium hydroxide. When we look at the charges of sodium and hydrogen, these substances are having same charges, meaning between the two there will be a competition. Which one is going to win? The chloride. When we look at sodium is more reactive than hydrogen. So hydrogen is going to be displaced from its acid, and sodium is going to take the position of hydrogen and form sodium chloride, which will be a salt. Now this hydrogen ion which is going to be displaced will have no option but to react with the hydroxide in order to form water. The two substances which have been formed, which is sodium chloride and water, are neutral substances. That's the reason why we are saying the method we are using is neutralization, because a base, sodium hydroxide with the pH of about 13, will react with hydrochloric acid with the pH of about 1, and at the end of the day the two substances will neutralize each other to form the substances sodium chloride and water that are going to have the pH of about 7. Therefore, we qualify now to call the method of preparation to be known as neutralization. So this is what we can observe. The products we are going to have sodium chloride and water. And the reaction we are saying, we are reacting sodium hydroxide plus an acid to form sodium chloride and water. Now, we can be questioned to give our equations ionically. How are we going to present our answer? So we are going to write an ionic equation. So we are reacting sodium hydroxide in aqueous state plus HCl in aqueous state. This will give us sodium chloride in aqueous state plus water in liquid state. What are we going to do? Under ionic equations, we have principles we follow when we are writing equations ionically. We understand that the first step we are supposed to undertake is to make sure that the equation is well balanced. So you need to check this equation so that you are sure that the equation is balanced. When you check the number of sodium atoms on the reactant side, we have 1. Even this side we have 1. Oxygen we have 1. This side we also have 1 from water. Hydrogen we have 1 on the hydroxide and 1 on the acid, so we have 2 on the reactant side. On the product side we also have 2. The chloride we have 1 and we have 1, meaning we are going to say this equation, the equation is balanced by inspection. Why am I talking about this statement? This statement is very important in your exam. This is the only way you are going to tell your examiner that you checked the equation and you discovered that the equation was already balanced. You are not supposed to leave the equation just like that, because on the questions, before they ask you to write an ionic equation, they are going to ask you to write a balanced chemical equation of the reaction between sodium hydroxide and hydrochloric acid. Now, when you write that equation, you need to make sure that the equation is balanced. And if you discover that the equation is already balanced, you are supposed to give them the statement so that they are going to give you a mark, because this will be a proof enough that you checked the equation and it was balanced. From this step, that's when now you can proceed to the next step, where you are going to ionize the substances only existing in aqueous state. So we understand that sodium hydroxide is in aqueous state. So we are going to say sodium hydroxide. We are going to ionize by splitting the metallic part from a non-metallic part. Sodium is a metal, so it will ionize with the state symbol, plus the hydroxide itself is a radical. Never should you attempt to dissociate oxygen from the hydroxide, because this hydroxide is a radical. In a radical, atoms exist as a group of atoms and they deserve to be respected in that manner. When you are ionizing, never should you temper to dissociate the atoms that are existing as radicals. So we are going to say sodium ion aqueous, hydroxide ion aqueous. This is reacting with hydrogen, or should I say hydrochloric acid aqueous plus a chloride in aqueous state, and this will give us sodium chloride, which will be also in aqueous state, plus there, and then you say aqueous state, then plus water. In liquid state. So at this stage now, you are supposed to cancel out the spectator ions. Spectator ions are those ions that will be existing in the same state, same charge, and the same symbols. We understand that the chemical reaction only takes place when the new substance has been formed. So we are not going to say the new substance has been formed if the substances are still maintaining their state. So we are going to say sodium. On the product side, we have sodium ion, negative charge, aqueous, and same symbol. So we are going to say these ions are spectator ions. So a chloride and a chloride will go, sodium and sodium will also go. So finally, we are going to remain with the hydroxide ions in aqueous state plus the hydrogen ion in aqueous state, that is going to give us water in liquid state. When we arrive at this answer, this is going to be our net ionic equation. Moving forward, so now we know how to arrive at this answer because I have demonstrated on how we are supposed to write an ionic equation. Method of preparation. Now, you need to understand that when we are reacting an alkali, which is sodium hydroxide, with an acid such as hydrochloric acid, we use an experiment known as titration experiment. What are you supposed to do? You understand that in titration, an indicator is used. This indicator, in most cases, we use phenolphthalein. We can also use some other indicators such as methyl orange, bromothenol, or something you feel like. Now, there are some concepts you are supposed to understand. Why are we going to use an indicator? An indicator is going to help us to tell the end point of the reaction. More especially that you are not going to know the end point of the reaction, an indicator is going to change the color and indicates that the reaction now is over. Because when you mix sodium hydroxide plus hydrochloric acid, these two substances are colorless substances. And what is going to be produced will be also colorless product. So it is not possible as for you to know that the reaction is over. That's the reason why you need an indicator to give you the information that now sodium chloride has been formed plus water. You understand that in aqueous state, sodium chloride is colorless. Water is also colorless. So you cannot tell, and there will be no bubbles that are going to be formed to inform you that now, since we are not able to observe bubbles, the reaction is over. In this reaction, there's nothing like that. Therefore, you need an indicator which will be able to indicate and communicate to you that now the reaction is over. That is very important. So, the first step, we are going to pipette or measure 25 centimeter cubic of sodium hydroxide and put it in the conical flask. From there, you are going to add 3 drops of your indicator to sodium hydroxide. You are going to use a pipette or pipette so that you can put the indicator to the conical flask containing sodium hydroxide. When you do that, the second step, you are going to fill the burette to the 0 reading with dilute hydrochloric acid. When you do that, you are going to place the conical flask on white tile below the burette. From there, you are going to add dilute hydrochloric acid from the burette to sodium hydroxide in the conical flask while swirling until the mixture just change the color. So immediately you see that the color of the indicator has changed. That is going to communicate that the reaction now is over. As you can just see the setup itself, this is how you are supposed to arrange your titration kit. We are having a burette and we are having the conical flask. The conical flask is containing sodium hydroxide and the burette is containing dilute hydrochloric acid. When you set your titration kit in this manner, then now you can start your experiment so that you know the amount of an acid that is going to react with 25 centimeter cubic of sodium hydroxide. When you see the color change, then you are going to close the tap and take the reading of hydrochloric acid used. From there, you are going to form a relationship that if it is going to react with 20 centimeter cubic of dilute hydrochloric acid, you can come up with a sentence that you just need 20 centimeter cubic of hydrochloric acid to react with 25 centimeter cubic of sodium hydroxide. So that is titration experiment. I'll find time and see to it that if at all possible, I can come up with a video on the experiment, basically on the preparation of sodium chloride. So we said another method of preparing a soluble salt is by using insoluble metal oxide, reacting that insoluble metal oxide with an acid. How are we going to do this, my dear learners? So we are going to attempt to prepare copper 2 sulfate. Now, again here you need to be careful. The examiner may ask you a question. They may demand you to mention two possible reagents that can react to form or to prepare copper 2 sulfate. I want to explain because many of the times learners give wrong answers pertaining the same question. Now, what we want to prepare here, my dear learners, is copper 2 sulfate. In this copper 2 sulfate, we have a transition element copper 2. Remember that transition elements have variable valencies. In this case, you need to understand when you are mentioning the reagents you are using. So, since we are preparing copper 2 sulfate, the reagent we are supposed to use should be copper 2 oxide. Never should you say copper oxide. When you say copper oxide, you are talking about a different compound. Copper 2 oxide is a different compound which has a different color. Copper 2 oxide is black in color. Copper 1 oxide is red in color, meaning those substances are having different properties. Now, this copper 2 oxide will give us the metallic part of the salt, which is copper, and the sulfuric acid will give us the sulfate, which is there in a salt. Therefore, copper is going to give us copper 2, and a sulfate will give us, the sulfuric acid will give us a sulfate. And at the end of the day, we are going to prepare a desirable salt. So how is the reaction going to take place? My dear learners, understand that copper 2 oxide is an insoluble base. Therefore, since copper 2 oxide is an insoluble base, we expect the reaction between copper 2 oxide and sulfuric acid to be slow. Therefore, we need now to think and give some factors that can promote the faster occurring of the reaction. So when we start looking at the procedure, you are going to understand that this acid is going to be warmed so that the temperature itself can facilitate the dissolving of copper 2 oxide, because in the structure of copper 2 oxide, ions are not able to move. Not until copper 2 oxide start dissolving, that's when it is going to react with sulfuric acid. Now the rate of dissolving is going to be very slow if the temperature of sulfuric acid is also low. Therefore, when we increase temperature on sulfuric acid, we are going to increase the rate of effective collision between the particles of copper 2 oxide with that of an acid. Therefore, we are going to say copper 2 oxide in solid state will start reacting with dilute sulfuric acid, and the products will be copper 2 sulfate plus water. Again here I'm going to state that this is still neutralization because we are having copper 2 oxide, which is an insoluble base, reacting with an acid. These two substances will be neutralizing each other, and what is going to be formed are soluble substances that will be neutral on the pH scale. And the products we are going to have at the end of the day are copper 2 sulfate plus water, as you can observe on the products formed. The procedure. Remember that the reaction is between copper 2 oxide in solid state, sulfuric acid in aqueous state, where we are going to form a blue solution, which is copper 2 sulfate plus water. Very important, my dear learners. Method of preparation. The examiner may demand you to prepare an hydrated copper 2 sulfate. When we say hydrated copper 2 sulfate in solid state, it means we need to convert this aqueous substance we have formed here. For example, this copper 2 sulfate. This copper 2 sulfate we have formed is in aqueous state. Now, this aqua means there is water. The color of the solution is going to be blue. And what is going to cause this color to be blue is because of the presence of copper ions. Remember, my dear learners, we discussed that copper is a transition element, and transition elements have the chemical property of forming colored compounds. So the presence of copper 2 in a sulfate or in the solution is going to cause this solution to be looking blue. Since the color of copper 2 sulfate in aqueous state is blue, we need to maintain the same color even if we convert this substance into a solid state. Now, we are not going to maintain the color of copper 2 sulfate if at all we are going to remove all water molecules from the solution. Therefore, we need to prepare an hydrated salt of copper 2 sulfate, meaning in the crystals of copper 2 sulfate, we are supposed to remain with some number of moles of water in the salty crystal. Those number of moles of water will maintain the color of copper 2 sulfate. When we remove the entire water, the color of copper 2 sulfate is going to change from blue to white. We are not interested in white copper 2 sulfate. We are interested in copper 2 sulfate, which is going to have the original color of blue. That's the reason why we prepare hydrated salt like this. It will have certain number of moles in structure. Now, here is the procedure. The first step, you are going to put dilute sulfuric acid in the beaker. You warm the acid, but remember not to boil. I told you that this is very important since we are using another reagent known as copper 2 oxide, which is an insoluble salt. In that structure, the particles are not free to move, and the reaction will only take place when the particles are able to collide effectively. That's the reason why we need to warm that acid, so that when we add an insoluble metal oxide to that acid, that insoluble oxide is going to dissolve because of the increased temperature. Now, upon dissolving copper 2 oxide, now we have free ions that are going to be moving, and when they are moving, they are going to react at the end. Add an excess of copper 2 oxide to the acid in the beaker and stir until the reaction is over. Understand, my dear learners, very important. Add an excess of copper 2 oxide. Why are we adding excess of copper 2 oxide? And why is it important that you should be stirring the mixture? Number one, when we stir the mixture, it's more like we are promoting the motion of particles. Because I told you that the reaction will only take place when ions in the mixtures are able to move. So as we stir, we are going to be promoting the motion of particles. And we are saying this copper 2 oxide need to be in excess. This is to ensure that all the sulfuric acid is converted to copper 2 sulfate. What we want to prepare is the neutral substance copper 2 sulfate. That substance should be neutral, and that substance will only be neutral if it is not going to contain hydrogen ions. If we fail to remove all the hydrogen ions from the acid, we are going to prepare what we call an acidic salt. But we are not interested in an acidic salt, we are interested in a normal salt, which is going to be a neutral salt. So we need to make sure that copper 2 sulfate is in excess to ensure that all the acids will be displaced from an acid. All the hydrogen ions should be displaced from an acid. Point number 2. Or before I even explain the point number 3, let me comment on something scientifically. Since we are adding excess copper 2 sulfate, should I say copper 2 oxide to sulfuric acid, how are you going to tell that the reaction now is over? You need to look at an important point. When the Caramba. I'm okay, how are you? Okay, I'm very much sorry I was disturbed by echo. I'm very humbled, forgive me. So I was trying to explain on how you are going to tell that the reaction between sulfuric acid and copper 2 oxide is over. How are you going to know? You need to understand that this copper 2 oxide is black in color, and when you add it to sulfuric acid, it is going to make that acid also to be looking black. So the only way you are going to tell that the reaction is now over, you need to observe if the copper 2 oxide are dissolving or not. If they stop dissolving, you are going to know that the reaction now is over. That is very important, because you are adding this substance in excess, meaning some of the substances will remain unreacted. When you see that they stop dissolving, you are going to know now that the reaction is over. Now, we go to the third point, where we are saying you need to filter off excess copper 2 oxide to have a blue solution of copper 2 sulfate. Initially, you are not going to see a clear solution of the product copper 2 sulfate because of the black substance which is going to be there mixed with the blue copper 2 sulfate that has been formed. So you need to filter off the excess copper 2 oxide so that you can remain with a clear blue solution of copper 2 sulfate. Now, what we want to prepare is something in solid state. If the examiner say, explain how you can prepare an hydrated copper 2 oxide or copper 2 sulfate crystals, explain how you can prepare crystals of copper 2 sulfate. It means that when you prepare your solution, you need to find a way of removing excess water from the solution so that you can form the crystals of copper 2 sulfate. For that reason, you are going to proceed to the second step. There are two questions that can come here. The question may say, explain how you can prepare aqueous copper 2 sulfate. If the question is saying, explain how you can prepare aqueous, it means at this point you do have prepared your aqueous copper 2 sulfate. But if the question is saying, explain how you can prepare the salty crystals of copper 2 sulfate, you need to continue. For example, we are going to continue because in our method, we are talking about copper 2 sulfate crystals. We are not saying copper 2 sulfate solution, but we are saying copper 2 sulfate crystals, meaning we need to come up with the solid copper 2 sulfate. So when you prepare your aqueous copper 2 sulfate, you need to remove excess water so that you can transform the particles in copper 2 sulfate solution into solids. That's the reason why we are saying you need to evaporate the filtrate. The filtrate is the blue solution you are going to get. You evaporate the filtrate to obtain a saturated solution. My dear learners, saturated solution is the solution which is formed when you evaporate excess water, and in that solution there's no more solute that is going to dissolve. What does it mean? The saturated solution is going to have just a small amount of water, and in that small amount of water, no more solute of those crystals that are going to be there will dissolve. Meaning, since they cannot dissolve, they will start forming crystals when you start cooling the solution. So when you prepare your saturated solution, you need to cool, because when you are cooling now, the particles will be coming together to each other. So you cool the filtrate in the ice bath to allow the crystals of copper 2 sulfate to be formed. That is very important, my dear learners. So understand the scientific points. You evaporate the excess water. You form a saturated solution. When you form a saturated solution, you are going to cool the saturated solution. Why are you cooling this saturated solution? So that you can promote the formation of crystals of copper 2 sulfate. Because by cooling, you are decreasing the temperature, and when you decrease the temperature, the particles now will be formed. That is very important, my dear learners. Very, very important. Before I conclude my lesson, I am going to look at an exercise just to test your understanding. You are going to pause the video so that you can test yourself if at all you are able to remember some concepts or not. Very important. This is an exam question. It was extracted from an exam past paper. Let us look at the question. If I see that it is very simple, I will just leave it for you. Copper 2 sulfate crystals are soluble in water. Describe how these crystals could be prepared from a named acid and a suitable compound of copper. This is the very important question. Copper 2 sulfate crystals are soluble, meaning they are able to dissolve in water. How can you prepare the solid crystals of this copper 2 sulfate when it is in aqueous state? So you are going to prepare by reacting copper to oxide. This is the basic substance we are going to identify, because we are identifying the possible reagents. And an acid is going to be sulfuric acid. Why am I going to select only the two reagents? I am looking at what I am preparing. I am preparing copper 2 sulfate. I understand that this copper 2 oxide will give me the metallic part, which is copper, and the sulfuric acid will give me a sulfate which is there in copper 2 sulfate. Meaning I have identified an acid, I have also identified a compound of copper. The compound of copper here is copper 2 oxide. Very important. When you identify, it means now you are going to use the procedure we used above. what is going to be formed now will be copper 2 sulfate in aqueous state plus water. Then from here, since this copper 2 sulfate will be in water, we need to follow the procedure I am explaining. So you follow the same steps and then we are going to answer this question. I'm very excited as I conclude this lesson because I know that my capable learners will get something, and at the end of the day, they are going to perform wonders in their exam. Thank you so much for being there for me, and I know you are not forgetting to subscribe. Continue watching my videos and I am promising to do the best just for you. For now, I am going to say have a wonderful day.